Okay, hello everyone. Myself Mukesh Kumar Tiwari from LPM Public School. Dear student, today we have to talk about the new topic, and the topic name is the law of chemical combination. This is very important topic for you, so be serious during this topic. And you know that in my previous video I already talked about for the two major things, that is the significant figures and the scientific notation. And I hope that both these two topic are clear to you. If you have any problem, then you can ask me your question related to the significant figure as well as the scientific notation. Now today our topic is law of chemical combination. So, so now we going to start. The topic is law of chemical combination. Law of chemical combination. Law of chemical combination is the topic. Clear? So, first of all, as you know very well that the everything is our surrounding is the matter, and matter have a very smallest part, and that smallest part is known as atom. Clear? And you know that how the atoms are combined to form the molecules, and molecules are a stable form, so on. Now in this unit we have to talk about the almost 5 laws, and these laws are considered as the law of chemical combination. Clear? So one by one I have to discuss the law. The first law is law of conservation of mass. Law of conservation of mass. Second one is the law of definite or constant. Law of definite or constant proportion. Third one is the law of multiple proportion. Law of multiple proportion. Fourth one is the law of reciprocal. Law of reciprocal proportions. Law of reciprocal proportions. And the last one is the law of or Gay-Lussac law of Gay-Lussac law of combining. Gay-Lussac law of combining volumes. So in law of chemical combination we have to discuss about these 5 laws one by one. The first one is the law of conservation of mass, then law of definite proportion or constant proportion, then law of multiple proportion. The fourth one is the law of reciprocal proportion, and Gay-Lussac law of combining volume. Clear? So out of these 5, the 4th one is directly concerned with the mass relationship, and the last one, that is the 5th law, is the related to the volume. Clear? So you have to note here that in your class 11 you have to not consider, or law of reciprocal proportion is not included in your NCERT. Clear? So we have to only talk about for law of conservation of mass, law of definite proportion, law of multiple proportion, then Gay-Lussac law of combining volumes. Clear? So we going to start law of conservation of mass. First of all, you have to know about this topic that this law was first of all established by a very famous French chemist named was Antoine Lavoisier. This law is first of all established by or given by French chemist named was Antoine Lavoisier. Antoine Lavoisier, very important. As you know that this name is also the father of chemistry. Clear? So the law of conservation of mass established by the French chemist named was Antoine Lavoisier. Now we are going to start what is the law of conservation of mass. Clear? So listen the words things very carefully. As you know that in a given chemical reactions, we generally observe that reactant or changes into the product. In most of the chemical reaction, we consider that the chemical reactant or changes into the product. Clear? So first focus on, in every chemical reaction, reactants or changes into the product. Reactants or changes into the product. Clear? Now, in the law of conservation of mass, it has been told that when any chemical reaction being proceed or being takes place, then there will be no any detectable change in the mass of the reactant or in the product. That means when any chemical reaction will occur, the mass of reactant be as the same as the mass of product. That means suppose we are talking about for a reaction A plus B, this is changes into the C. Clear? So in this reaction, A is the reactant and B is also the reactant and C is the product. Clear? Suppose A is given 20 gram and B is given as a 10 gram. Clear? So after adding or after the reaction between A and B, we get 30 gram of C. Clear? And after all, when we add this mass A and B, that means we get also the reactant mass is also the 30 gram. Clear? And product is also 30 gram. That means in any given reaction, the mass of reactant it becomes or equal to the mass of product. Clear? As shown in this reaction. Clear? Now I will talk about for the second most example for any given chemical reaction. So what is the law or law of conservation of mass? In this law it has been given that in all type of the physical or chemical changes, the total mass of the product is the same as the total mass of the reactant. In any, once again, in law of conservation mass, it has been given that in all physical or chemical changes, the total mass of reactant is the total mass of the product is the same as the total mass of the reactant. Clear? Now we talk about for a reaction C plus O2, it gives CO2. And as you know very well that the mass of carbon, is 12. As you know, the mass of carbon is 12 and okay, so atomic mass of carbon is 12 gram and oxygen is 2 into 16, that means it is 32 gram. Clear? And after all we get 44 gram of carbon dioxide. Clear? So after adding these two, 12 gram and 32 gram, we get 44 gram of carbon dioxide. Clear? So in this way, Anthony Lavoisier suggested that in many more chemical reactions, the mass is remain as the same as, that means the mass of reactant are equal to the mass of product. Understand? Now there is another activity are given to show that is mass of reactant or product are becomes equal to each other. So the activity is that silver nitrate, that is AgNO3 solution, is mixed with the sodium chloride solution. When silver nitrate solution is mixed with the sodium chloride solution, then silver chloride, that is AgCl, and sodium nitrate, that is NaNO3, is formed. This silver chloride gives the white precipitate, white curdy precipitate, and this white curdy precipitate have, that means there is an apparatus have been taken, and in one side of the apparatus the silver nitrate solution have been filled, and in the second types of the test tube, you can say the apparatus also. Clear? In the second test tube the sodium chloride solution have been placed, and after tilting these two test tube, the silver nitrate mixed with the sodium chloride and the sodium chloride mixed with the silver nitrate. Clear? So in this way, in the both the test tube, there is a formation of compound known as the silver chloride, which gives the white curdy precipitate. And the mass of the white curdy precipitate in the first test tube as the same in the second test tube. So in this way we can say that the law of conservation of mass is applicable for every types of the given chemical reaction, and this was the prediction of Anthony Lavoisier also. Now we talk about, nowadays this law of conservation of mass is not applicable in most of the reaction. For example, rusting in iron is an example for, or the limitation for the law of conservation of mass. Clear? And the second thing is that after all, equation derived by the Einstein E is equal to mc square. This equation also gives that the law of conservation of mass is not applicable in most of the cases. Clear? So now we are talking about for the second law of chemical combination, and the second law of chemical combination is the law of definite proportion or law of constant proportion. Clear? So we are going to start the second law, law of definite proportion. Law of definite or constant proportion. Law of definite or constant proportion. Clear? So in this law, first of all we talk about, for this law was first of all established by or given by French chemist named Joseph Proust. Clear? This law was given by French chemist named Joseph Proust in 1799. Now we have to focus what was the suggestion of Joseph Proust. Clear? So Joseph Proust suggested that when any compound is formed, after all you know that the compound are formed by the combination of two or more elements in a definite proportion by their weight. Clear? So here Joseph Proust suggested that a pure chemical compound always consists of the same element combined together in a fixed proportion by weight. Clear? So this is the law of constant or definite proportion. Now I will talk about for this law by a given or suitable example. Suppose we talk about for water. We talk about for water. What is the sources of water in our surrounding? Water. So water have different sources like lake water, pond water, sea water, rain water, groundwater, so on. These are the main sources of the water, and you know very well that the formula of the water is H2O. H2O. Clear? So this formula of water can be changed when we take the water from the lake or pond or sea or rain or ground? No, because the composition of the water remain as the same either we take the water from any other sources like the sea water, pond water, rain water, ground water, so on. Clear? So in this way we can say here what will be the proportion of the hydrogen and oxygen in the water. Clear? So in H2O the two elements hydrogen and oxygen are given. Clear? And the number of hydrogen atom is 2, so the mass of hydrogen atom will be also 2, and oxygen is only 1, and the atomic mass of oxygen is 16. And after simpling these two we get 1:8. That means in water the ratio of hydrogen and oxygen will remain as 1:2. Either we get the water from the lake, pond, sea, rain or ground. Clear? That means the proportion of the proportion of the hydrogen and oxygen in water will be remains fixed or definite, that is 1:8. This will not be changed in any conditions. Clear? Similarly, we talk about for the second thing or second compound. The name is carbon dioxide. The name of the second compound is the carbon dioxide. Carbon dioxide. Clear? So the carbon dioxide is CO2. And what is the sources of the carbon dioxide? So the carbon dioxide we get from after calcination of the calcium carbonate CaCO3, we get CaO and CO2, that is calcium oxide and carbon dioxide. The second important or the second method to get the carbon dioxide is after heating the sodium hydrogen carbonate, we get sodium carbonate, Na2CO3, water and carbon dioxide. And after all, you know also that after the combustion of the carbon we get also carbon dioxide. So these are the some important sources to get the carbon dioxide in the our surrounding. Clear? So another form of the carbon dioxide to take the respiration, so on. So here carbon dioxide we get from these all sources, and after all you know that in these all the ratio of the carbon and oxygen in carbon dioxide will be remains as the same like this. In carbon dioxide, you know that there are two elements, carbon and oxygen are present, and the mass of carbon is 12 and oxygen is 32, because two oxygen are given. One oxygen have 16 and the two oxygen have 32. So after simplify, we get 3:8. Clear? That means in carbon dioxide, the ratio of carbon and oxygen will be remain as a 3:8. That means this will be a definite or constant proportion of the carbon and oxygen in carbon dioxide. Clear? So in this way we can say that what is the law of definite proportion or law of constant proportion. Clear? Now I will talk about for the second, that means the third law of chemical combination in my next video. So watch my video. Thanks a lot.